Hello, hello. This is Math 208. Today we're covering section 3.2. This is lecture number 2. I'm going to cover section 3.2 compound interest, continuous compound interest, and logarithm rules. And I'm going to cover that in this lecture. And then we're going to do a couple of the example problems. And then I'm going to come back and I'm going to do annual percentage yield, which is also 3.2. So let's get started. Now, previously we had covered simple interest, which basically says you have a term, you get paid the interest and the principal at the end of that term, which is wonderful. So say that at the end of that term, let me turn off my camera here so that we have full screen on this. There we go. So say that at the end of the term, the principal along with the interest is reinvested. This kind of underlies the concept of compounding interest, so that at the end of each compounding period, interest is added to the principal, and the rate of return, the interest rate, is now applied to that compounded total. And for this, we basically have two formula. They're very similar to each other. Formula number 4 and formula number 5. And that is the amount is equal to the present value, or the principal, times, in the case of number 4, in the case of the first equation, times 1 plus I to the nth power. Now I is the decimal rate per compounding period, and n is the number of compounding periods. Now these two equations are similar, and typically we're going to end up using the second one. There are occasions when you're going to use the first one, but typically we're going to end up using the second one. And for the second one, the future value is equal to the present value times 1 plus the rate divided by the number of compounding periods in a year to the number of compounding periods in a year times t, the number of years, to that power. Given this equation, you should be able to solve for any unknown value given the other values. I'm going to say that, except I don't think in any of the questions that we have do we solve for m. We will have to solve for t, and it's one of the reasons why I'm going to cover logarithm rules. We'll come back to the examples in a little bit. Continuously compounded interest. The difference between compounding interest is typically we're talking a compounding period that is semi-annually, quarterly, monthly, but it generally doesn't get much shorter than that. But if you were to think about it, as your compounding period gets shorter and shorter and shorter, so you have more compounding periods in a given time, so your period gets smaller, let's say minutes and then seconds, we eventually say that it becomes continuous. And we'll look at limits and stuff, which is basically what this is, later in chapter 9, but we don't need to worry about that right now. For right now, we have a pretty basic formula for that, and that's this formula. Right here. So the amount, the future value, is equal to the principal times e to the RT. Now, e is the irrational constant known as Euler's number. You should be able to find it on your calculator. If you don't, it is a number that you are definitely going to be using in business school, so you might want to consider what type of a calculator you're using. The R, again, is the decimal annual interest rate, and T is the time in years. Once again, you should be able to solve for any unknown given the other values. We'll come back to these problems a little bit later. I just want to quickly review logarithm rules. Now, the logarithm rules is algebra. It's probably been a little bit since you've used them. If you're not familiar with them, this is a refresher for it. We have the product rule, the quotient rule, the power rule, the identity for log base 10, and the identity for log base e. Now, generally we call log base e the natural log. And then we also have the 0. So the product rule, that's the first one. If we take the log of a times b, that's equivalent to the log of a plus the log of b. The quotient rule which we will definitely use in a number of our questions, is the log of a divided by b is equal to log of a minus the log of b. The power rule, which again we'll also use, is the log of a to the p is equal to p times the log of a. We may use this one. We may use the log of base 10, but generally speaking, we'll probably use the log base e. So ln of e is equal to 1, and the log of 1 is equal to 0. We're going to need these logarithm rules when we look at our compounding interest rates and our continuously compounding interest rates to solve for t. So that ends this lecture, and the next one will be on running through the examples that we have here.